Hello dear children, in today's class we will be solving the numericals based on projectile motion concept. Dear children, in the previous classes we covered the all concepts related to the projectile motion. So links will be given in the description, just go through those videos in order to get the full command on the concepts. So in today's class we will be solving the almost 10 numericals, 10 very important numericals based on the projectile motion. So now let us see the first numerical. Dear children, as per the first numerical, a body is projected with the initial velocity of 30 meter per second such that it makes an angle 30 degrees with the vertical. Then they are asking us to calculate the time of flight, maximum height reached, and the it's a range also, range covered. So here first let us see the time of flight. So we know that time of flight is equal to 2u sin theta by g, but theta is equal to, yes, theta is equal to 30 degrees. When you write theta is equal to 30 degrees, when you substitute you will get a wrong answer. Why? Here theta is what? Angle of projection, angle of projection. So here angle of projection means how much actually? So this is the angle of projection, right? This is the angle of projection. So as it is 30 degrees, so here theta is equal to how much, dear children? 60 degrees. So theta is equal to 60 degrees is the right actually. Okay, now let us substitute in this. So this is going to be 2 into 30 and sin 60 is root 3 by 2 by 9.8. 2 will get cancelled. This is going to be a 30 into 1.732 by it is 9.8. If you substitute, you will get 5.3 seconds. So this is the time of flight. So here again I am telling you should be very careful. So here 30 degrees is given. Here it is making angle theta with 30 degrees with the vertical. But angular projection is what actually? So here to horizontal, from horizontal we will take. Okay, fine. So this is theta. Okay. Now second one we need to calculate the maximum height. So this is going to be u square sin square theta by it is 2g. Let us substitute here. U square means 30, right? So it is 30 into 30 and sin square theta. Sin theta is root 3 by 2. Root 3 by 2 whole square, that is 3 by 4 by it is 2 into 9.8. 2 into 9.8. So if you can see 2 2s are 2 15s, 2 1s are 2 15s. So this is 15 15s are 225 into 3 by 2 into 9.8. So if you can simplify this, you will get 34.4 meters. This is a maximum height reached. This is a time of flight. Time of flight. And the third one, the children, they are asking us to calculate the range. So range formula is what? U square sin 2 theta by g. So u square means what? 30 square, that is 30 into 30 and sin 2 theta. Theta is a 60 degrees. Sin 2 theta is what? Sin 120. Sin 120 by 9.8. Sin 120 is how much? Sin 120 can be written as 90 plus 30. Sin 120 can be written as sin 90 plus 30. So this is going to be a, here it is a 90, right? So sin will become cos 30 degrees. So 90 plus theta comes in the second quadrant. In second quadrant sin is a positive. So cos 30. So sin 120 is nothing but cos 30. Cos 30 is what? Root 3 by 2. So this is going to be sin 20 value. We can write here it as a root 3 by 2. Root 3 by 2. So here 2 1s are 215. If you simplify this, you will get as a 79.53 seconds. So this is how you can calculate the time of flight, maximum height reached, and here is a range. Is it clear? Okay, now fine. Now here is a second numerical. It is given that here a body is projected with a 40 meter per second. Initial velocity at the time is equal to 0. Its initial velocity is 40 meter per second. Such that it crosses the, very important, it crosses the, what we can say, a tower of height 20.4 meter, means after 2 seconds, when it is fired with a 40 meter per second velocity, after 2 seconds, it it crosses the tower of height 20.4 meters horizontally. So it's very important. We know that the trajectory of the projectile is a parabola. But once it is fired, at what point it will go horizontal, it will have a horizontal velocity? Yes, at a maximum height. So indirectly, here the height of the tower is nothing but the maximum height reached. So here, let us write the data given. So initial velocity is 40 meter per second, and here also given what we can say maximum height reached. So this will be 20.4 meters and g value is given. Then they are asking us to find the what we can say angle of projection they are asking. Okay, fine. And here why I wrote here r by 2, half of the range. Yes, means maximum height is where the point where height of what means the range will be half, right? Okay, now fine. So here maximum height formula. So what the maximum height formula here? Yes, u square sin square theta by 2g. But maximum height is given 20.4. 20.4 is equal to u square. So 40 into 40, this is sin square theta by it is 2 into 9.8. So let us write sin square theta is equal to, so this is okay, sin square theta is equal to 20.4 into 2 into 9.8 by this will be 40 into 40. So if you can simplify this entire thing, you will get it as a 0.25. So here sin square theta, children, 0.25 can be written as 0.5 whole square. As sin square theta is equal to 0.5 whole square, sin theta is equal to 0.5. 0.5 is nothing but 1 by 2. So for what angle of sine, the value will be 1 by 2, sin 30. So this will be sin 30 degrees. So as sin theta is equal to sin 30 and the theta is equal to 30 degrees. So children, so this is a angle of projection. So angle of projection is how much? 30 degrees. Okay, na? Just copy this and we will continue with the other numericals. Is it copied? Can I raise? 3, 2, 1. Yes. Is equal to how much? Okay, children. So as per the numerical 3, it is given that so two bodies are projected such that so theta 1 is the angle of projection of first body and theta 1 is the time of flight for that body, and theta 2 is the angle of projection for second body, and theta 2 is the T2 is the time of flight taken for a second projectile. Okay, na? And both are projected such that theta 1, theta 2 are the angle of projections and T1, T2 are the time of flights. And a condition is given, they are projected such that theta 1 plus theta 2 is equal to 90 degrees. This is a condition given. Theta 1 plus theta 2 is equal to 90 degrees. So then they are asking us to find the product of T1 and T2. So what is the product of T1 and T2? That is the product of time of flights of two projectiles which are thrown with a two different angle of projections. So now we know that actually T is equal to 2u sin theta by g, right? Okay. Now first let us write for T1. So T1 is equal to 2u sin theta 1 by g. Okay. For a second one, T2 is equal to 2u sin theta 2 by g. But theta 2 is equal to what I can write? So from this, children, can I write like this? Theta 2 is equal to 90 minus theta 1. And don't forget that both are projected with the same initial velocity. Okay, na? Yes. And here this is going to be 2u sin, in the place of theta 2 you can write 90 minus theta 1 by it is g. So theta 2 is equal to 2u sin 90 minus theta 1 is nothing but the cos theta 1. Okay, fine. So this is 2u cos theta 1 by g. Okay. So now let us see the product. T1 into T2 is equal to, T1 value is how much? 2u sin theta 1 by g into 2u cos theta 1 by g. Okay. So from this, can we write like this? So what can we write here? 2 by g. 2 by g, let us take here, and u into u square it is 2 sin theta 1 cos theta 1 by g. Children, 2 sin theta cos theta is nothing but the sin 2 theta, right? Okay, let us apply that. So then this is going to be 2 by g u square sin 2 theta 1 by g. But dear children, this u square sin 2 theta by g is nothing but the range. It is nothing but the range. So this is going to be 2 r by g. So the product of T1 and T2 is equal to 2 r by g. That's it. Okay, fine. And just comes to the fourth numerical. It is given that, so a body is projected with an initial velocity of 49 meter per second such that it makes an angle 30 degrees with the horizontal. Means what? Here this is the angle of projection is given, and they are asking us to find the what is its velocity after 2 seconds. After 2 seconds, children, as it is the initial velocity, let us say it is u. So we know that projectile motion is a two-dimensional motion, so that its velocity can be resolved into two rectangular components. So first let us calculate its horizontal component. Ux is equal to u cos theta. So this is going to be 49 into cos 30. Cos 30 is how much? Root 3 by 2. So this is going to be 2 2s are 4, 2 4s. So 24.5 root 3 meter per second. Children, this is a horizontal component and it remains constant throughout the motion, because in a horizontal direction there won't be any force. Okay, so horizontal velocity of a projectile always remains constant. Okay, fine. Now, so vertical component, initial component u sin theta. So this is initial velocity, 49, and sin 30 is 1 by 2. Sin 30 is 1 by 2. So this is going to be 24.5 meter per second. So we got here horizontal component and here we got a vertical component. But dear children, after 2 minutes, after 2 seconds, horizontal component remains same only, but vertical component of the velocity keeps on changing. So how to find out? Okay, so after 2 seconds, so Vy is equal to, it is Uy minus gt. So this formula we use to calculate the vertical component of the velocity after time t, actually after time t. So substitute here, Uy is 24.5 minus g is 9.8, it is into 2. So if you can just what we can say, do this, so then you will get 4.9 meter per second. Okay, now after 2 seconds they are asked for, suppose here the body is here, let us say that. So this is its a horizontal component and this will be the vertical component, right? So this is going to be the resultant velocity v. So this we have to calculate now. So resultant velocity is equal to square root of, it is ux square plus it is vy square. So ux square is what, actually this entire term whole square we have to write. So 24.5 into root 3 whole square plus vy whole square is how much? It is 4.9 whole square. So this we have to simplify so as to get the value. So already I have done this actually. So this value is going to be 42.72 meter per second. So this is the velocity of the projectile after 2 seconds. After 2 seconds, and after 2 seconds it is making angle theta, right? It's making theta. So how to, so let us say this is not theta, let us say it is some beta. Then how to calculate this value also, let us see. So we know that the tan beta is equal to Vy by Ux. So it is a Vy value, how much we got? 4.9 by Ux value is 24.5 into root 3. So children, if you simplify this, you will get as a 0.1155. So tan beta is equal to 0.1155. So beta is equal to tan inverse of 0.1155. So this value is going to be 6.59 degrees. So children, this is how we can calculate the velocity of the projectile after some time t. Of course, here it might be 2 seconds. So whatever may be after time t. So this is a method, and after some time t, it makes some angle with the horizontal, right? So that value also how can we calculate means. So this is a process to be calculated. Okay. Yes, just copy this. We'll continue. So children, here you should be very careful actually with all these things. Okay. Copied. Okay. P is equal to T. Okay, children. So as per the numerical 5, here a body is projected from a top of a tower. Okay, try to understand. So, and the height of the tower is given, or else height of the building is given 25 meters. The first question is that they're asking us to find after how much time does it hit the ground. First question. And the second one is that we need to find the initial velocity. But one condition is the initial velocity if the point of projection and the point of hit where it is hitting the ground, that line makes an angle of 45 degrees with the horizontal, 45 degrees with the horizontal. So if it is that case, we need to find the initial velocity. Look at here, dear children. So it is a 45 means it has to be 45. Okay, na? Yes, no doubt. It is a 45 means anyhow it is a 90 only. So this has to be 45 degrees. Okay, fine. So from this, so let us say it's a O, A, let us say it's a B. So from this, if I can take a tan 45 degrees, so it is opposite side by adjacent side, that is OA by OB. So tan 45 is how much? It is a 1. So 1 is equal to OA is 25 and OB is yes. So from this first we got a horizontal distance, that is a 25 meters. Here S is equal to UT plus half AT square. Now here we need to calculate the time, right? Means indirectly we need to calculate the time of flight, means we need to consider vertical motion only. So this is going to be a vertical height, vertical initial velocity is a acceleration. So Sy is nothing but h. Children, so anything which we can take a vertical downward direction, we can take it as a negative. So the vertical height is 25. So this should be minus 25 is equal to, so here initial velocity of the vertical component of the velocity is a 0. So 0 into something will be 0 minus half. Why I am taking minus here? Because Ay is going to be g, right? So g is always negative downward direction. So into 9.8 into this is t square. So here minus 25 is equal to minus half into 9.8 into it is a t square. Minus minus cancel. So if you can simplify, t is equal to square root of it is 50 by 9.8. So this simplify. So we will get it as a 2.26 seconds. Children, this we can do directly also. So t is equal to square root of 2h by g formula. This formula also you can apply. Okay, so this is how we can calculate. Now the thing is that we need to calculate the initial velocity. This point is very important to be understood. So dear children, as it is making an angle 45 degrees, right, into 45 degrees. So if theta is equal to 45 degrees, dear children, yes, initial velocity in what we call horizontal component of the velocity is equal to vertical component of the velocity. How? Let me tell you. So that is u cos theta and uy is equal to u sin theta. Anyhow, cos 45 is 1 only, sin 45 is 1 only. So it is a u only, it is a u only. That's it. Okay, so this logic we are going to use here actually, initial velocity. So as u is equal to uy, so let us take here u is equal to uy. So uy can be calculated how, children? G into t. Okay, so g value is how much? 9.8 and here time is 2.26. So with this, if you can calculate u, that is u is going to be how much? So this is 9.8 into 2. So this will be approximately 22.15 meter per second. So this is how we can calculate. Okay, fine. Okay, now come to the numerical 6 here. Here body is thrown with an initial velocity of 10 meter per second, but from where? From the top of the tower, such that it makes an angle 30 degrees with a horizontal, and it hits the ground after some time, so that range is given 17.3 meters. Now they are asking us to find the height of the tower. They are asking us to find. Okay. So as the initial velocity is 10 meters per second, angle of projection 30 degrees. Let us calculate the horizontal component of the velocity, vertical component of the velocity first. So children here, okay, this numerical is over. Yes. So it is ux is equal to u cos theta. U is how much? 10. Cos theta and cos 30 degrees. Cos 30 is how much? Root 3 by 2. So this will be 5 root 3 meter per second. Now vertical component of the velocity will be u sin theta. So u is a 10, sin theta, sin 30, 1 by 2. So this will be 5 meter per second. So here we got a horizontal component of the velocity and a vertical. So this, if you can simplify, 5 into root 3, 1.732. So this you will get 8.65 meter per second. And a vertical component of the velocity, yes, anyhow here we got a 5 meter per second. Now thing is that we need to calculate the what we can say, they are asking us to find the time of flight. Okay, first let us calculate time of flight. The children, we know that horizontal component of the velocity can never change. It remains constant because in a horizontal direction there is no force acting. Means horizontal motion can be considered as a uniform motion. So in that case, directly we can write like this, right? So that is distance is equal to speed into time. So with this reference here, distance is nothing but range. So range is equal to, speed is horizontal component, time is capital T. So here T is equal to R by ux. R is how much? 17.3 and this is 8.65. So if you can solve this, I think approximately, yes, you will get as 2 seconds. 2 seconds you will get. 2 seconds. So this is a time of flight. Now they are asking us to find even the height of the tower, right? So children, here we know that S is equal to ut plus half at square. So here means vertical motion, we need to consider vertical motion, that is, so h is equal to uy t minus half. Why I am taking minus half? Because a into will be g anyhow, t square. So now let us substitute uy is equal to 5, t is equal to 2 and g value is going to be 9.8. Yes, so here h is equal to uy is how much, children? 5, t is 2. So this is 5 into 2 minus half into 10 into the 2 square. 2 gets cancelled. This will be 10 minus 20. So h is equal to, we got minus 10 meters. So children, why we got minus 10 meters? Because it's the vertical height, means this is a point of reference. So we measure vertical downward direction. So here, according to the sign convention, downward direction, what are the quantities which are taken as a negative? Okay, na? So this is actually the calculation here. See children, here you can use either this method or directly you can use this method. But when you are calculating, the initial velocity, it's very important. Here the clue is given that the line which is joining the point of projection and the point of hitting, it makes a 45 degrees angle with the horizontal. So hence this is 45 degrees. Means if the angle of projection, it's that is the angle is going to be 45 degrees. In that case only in that case only. So horizontal component of the velocity is going to be equal to the vertical component of the velocity. So that is the clue is given. So with that clue only we can solve this. And here is one more numerical. This is how we solved. Okay, fine. Range is equal to how much? Okay, so in a numerical 7, it is given, means they are asking us to find the angle of projection if range of the projectile is equal to the maximum height reached. So this is a clue is given. If r is equal to h, then theta is equal to how much? But the children, so we must know this. So what is the range formula here? We know that it is a u square sine 2 theta by g. Okay, and the maximum height reached by the projectile is u square, it is sine square theta by 2g. So these you should equate, so here, so u square sine theta 2 theta can be written as 2 sine theta cos theta by g, so which is equal to u square sine square theta by 2g. So u square g sine theta square cancel. So this will be 2 cos theta is equal to sine theta. Get this cos theta this side, so that is going to be sine theta by cos theta, and these two get this side, 2 into 4, this 4. Sine theta by cos theta is equal to tan theta, so tan theta is equal to 4 and theta is equal to tan inverse 4. So this is how we can calculate. Okay, fine. And here if you can see the ninth numerical, so quite interesting. A bus is going with a speed of 60 km per hour. Okay na, so from that bus a person, okay na, just he throws some object, let us not say stone, okay, let us stone, he thrown actually, try to understand, okay, and thrown from the window, so that the window is at a height of 19.6 meters from the road. Try to understand, means the distance between the height of the window is 19.6 meters. The children, as the moment, see the bus is going with a 60 km per hour. Obviously, the moment when the person leaves the ball also, the stone also moves with the same velocity. So at that point of the point where it is thrown, there it doesn't have any vertical velocity, only it has a horizontal velocity, that too equal to the speed of the bus. So it is nothing but the 60 km per hour. Okay, so let us say that from here it is thrown, so that stone will travel sometime with the bus, but it will go in a parabolic path. Let us say it is hitting this point. So now they are asking us to find this r value. Okay, fine. So dear children, we have direct formula. R is equal to actually u into time of flight. Okay, so it is ux only. It is a ux only. So now this is going to be ux into t is nothing but 2h by g. Okay, substitute the value here. R is equal to ux. Here only there is ux is equal to 60 km per hour. This we need to convert to meter per second, teacher. 60 into 5 by 18. 5 by 18. So 6 3s are 6 10s. So this is going to be a 50 by 3. So this will be 50 by 3 into square root of 2 into 19.6 by 9.8. So let us simplify this. This approximately will get some so 16.66 something you will get, and this if you simplify you will get 0.4. So this is going to be 16.66 into root 0.4 you will be 0.6324. So if you simplify this, you will get R is equal to 10.54 meters. So it travels, that stone travels and hits the ground, means meanwhile it will travel a distance of 10.54 meters. Okay, so this is how we can solve the 8th numerical. This is 10 meters below. Okay, so children, it's quite interesting numerical. So there are two buildings facing each other, okay na, and the distance between the two buildings, okay na, so is a 40 meters. In this building, let us say building A, okay na, it's a building B, and it is one window, it is another window. So from here, one boy is throwing some letter by keeping some stone. So from that to just he wants to what we can say throw to that one more person, like I say his friend who is in this building actually. So here is his window, and here it is given that this window is exactly, okay, so if you can see this window of a person, this building A is just lies below 10 meters, try to understand. So from this window the boy wants to throw so that it enters into this window exactly horizontally. So this is a clue given to us, exactly horizontally. Children, of course it is going in a parabolic path. So the point where it moves horizontally, exactly at a maximum height, So indirectly, so if you can see this is horizontal and this is going to be a maximum height. So indirectly here it is given that h max is equal to 10 meters is given. As it is the maximum height, it is going to be half of the range. that is half of the range. R by 2 is given 40. Then range is going to be 80 meters. Now they are asking, so how that what we can say that object should be thrown. Object means the paper means stone is placed, means with what initial velocity, with what angle it must be thrown, that we need to calculate. So children, for this, so let us take here maximum height by range ratio here. So maximum height formula is what here, we know that u square into sine sine square theta, sorry. So it is a sine square theta by 2g, and the maximum or range formula is what here, range formula is u square sine 2 theta. This is sine 2 theta by g. So now this will become here u square sine square theta by 2g into, this will be reciprocal, right, g by u square sine 2 theta. U square g cancel. So this will be 10 by 80, and this will be sine square theta can be written as sine theta into sine theta by 2 into sine 2 theta can be written as 2 sine theta into cos theta. So sine theta cancel, sine theta by cos theta will be tan theta. So this will be 1 by 8. So 1 by 8 is equal to 2 into 2 4, 1 by 4 into tan theta. Try to understand. So 4 ones are 4 twos are. So this will be tan theta is equal to 1 by 2. So children, if tan theta is equal to 1 by 2, the theta is going to be a tan inverse 1 by 2. So tan, so 1 by 2, it's nothing but 0.5, and its value is going to be 26 degrees 34 minutes. So with this much angle, that should be thrown. Okay. Then what about initial velocity? So this is the first part is done. Initial velocity. Okay. Let us take a maximum height formula, right? H is equal to u square sine square theta by it is 2g. So from this, can we write like this? U square is equal to 2gh by sine square theta. Yes, this is 2 into 9.8, h value is a 10 by sine square theta. So here as tan theta is equal to 1 by 2, so from this we need to calculate the sine square theta. How? So this is, look at here, so this is a theta, so this is opposite side is 1, okay na, and adjacent side is 2. So from this let us calculate hypotenuse. So hypotenuse square is equal to 2 square plus 1 square. So this will be 4 plus 1. So h square is equal to 5 and h is equal to root 5. This is root 5. Try to understand. So here, so from this tan theta is equal to how much? It is a opposite side by hypotenuse. That is, so sine theta is going to be 1 by root 5. 1 by root 5. Sine theta is equal to 1 by root 5 means sine square theta is 1 by root 5. It is whole square. So this is going to be a 2 into 9.8 into 10 by 1 by 5. So this will be equal to, so this is, this 5 will go to numerator, 10 5s are 50, 50 into 100. So 100 into 9.8. So let me do this here. No? So u square is equal to, so 100 into 9.8, it is going to be a 980. As u square is equal to 980, so u is equal to approximately 31.5 something we will get meter per second. So this how we can calculate the initial velocity. So that a particular object must be thrown from this window A with this much initial velocity and with this much angle, so that it will reach the window B exactly horizontally, and here the clue is that only, as it is passing this window horizontally, which means it must be a maximum height. As it is a maximum height means this distance between these two buildings must be equal to the half of the range. Okay, fine. (180 meters). So children, this is a today's session last numerical. So here two buildings are facing each other. It's very important. And here is one window is there. Let us say it's a building A window. Let us say window A. It's a window B. And here the clue is given. This window is at a height of 55 meters from the ground, and whereas this window is 10.9 meters from the ground. Then what is the distance between these two windows? 55 minus 10.9, that is going to be 44.1. And the distance between these two windows is given 180. Okay, 180. So children, it is nothing but if you can see, yes, the body is projected from the certain building of height 44.1 meter, right? Yes. Now they are asking with what velocity it should be projected horizontally, so that it should enter into this building. Means they are asking us to find the initial velocity. So children, we know that here r is equal to ux into time of flight, and r is equal to, so initial velocity into time of flight is nothing but 2h by g. Okay, so r is anyhow it is given 180, and the u value is going to be, of course, that we have to calculate, and 2 into, and the height is 44.1 by it is 9.8. So children, this is 180 is equal to u. If you simplify this whole, you will get root 9. So this is 180 is equal to u into 3. So u is equal to 180 by 3. This is 60 meter per second. So with this much velocity, it has to be thrown horizontally so that it will enter into this window B. Okay, children. So these are the few numericals based on the projectile motion, and if possible we'll try to have one more session where we'll cover a few more numericals based on the projectile motion. So dear children, as I told you that earlier from the beginning of this video, yes, we already covered the projectile motion and types of projectile motion in detail, and those links will be given in the description. Just go through those videos so that numericals, solving the numericals will become very easy to you all. Okay dear children, thank you so much, all the very best.